Welcome back. Today I'll discuss a question which has been sent to me by one of the students through message. Let's discuss this question. This deals with the situation of multiple charges where the whole system is in equilibrium. That means we have already discussed questions in our previous lectures that two charges are given and a third charge is to be placed somewhere in between or somewhere around here so that that third charge remains in equilibrium. In that case, the first Q1 and Q2 are given to be fixed. But what if none of the charges are fixed and still the system is in equilibrium? That means the net force not only on Q0 but on Q1 and Q2, that the force on each one of them individually is equal to 0. This is a beautiful question in which it says that there are two charges Q and 2Q separated by a certain distance, and a third charge Q0 has got distance. The distance between Q0 and Q is d times under root 2 minus 1, and it says the distance between Q0 and 2Q is d times 2 minus under root 2, and says find out Q0 if all the charges are in equilibrium. I know Q0 is placed somewhere over here. Its distance from this Q0 from Q is d times under root 2 minus 1, and from this it is d times 2 minus under root 2. I can sum them up and it automatically turns out to be equal to d. The total distance between Q and 2Q is d. You can simply sum them up and everything else will get cancelled out. Now, if I equate the force on Q0, Q0 will get cancelled out in the equation and I will not be able to find out Q0. So if I have been asked to find out Q0, I will not equate the force, I will not calculate the force on Q0. Rather, I will calculate force on either Q or 2Q. This is because I don't want the Q0 to get cancelled out. So let's find out force on Q. Since every charge is in equilibrium, Q is also in equilibrium, so net force on Q must be 0. Now, for equilibrium, obviously, since they are of same polarity Q and 2Q, this charge must be pushing it with some force F in this direction, and this charge has to be negative. That's why it's attracting it in this direction. And let's say the force again F, because it is in equilibrium, two equal and opposite forces are acting on it. So what is force between Q and 2Q? It will be constant of proportionality K times Q times 2Q divided by distance square. That has to be equal to the force exerted on Q by Q0, that is equal to K times Q into Q0 divided by d times under root 2 minus 1 whole square. Whatever get cancelled out has been cancelled out, and by cross multiplication, what do I get? 2Q times under root 2 minus 1 whole square is equal to Q0. You can further simplify it or leave it after this point only. You can, for simplicity, also open up this bracket. This whole square, it will become 2 plus 1 minus 2ab, 2 under root 2, a square plus b square minus 2ab. This is what I have done. This is equal to Q0. You can simplify it. You can put under root 2 as 1.4, it's 1.414, but just for mathematical convenience, you can just put it as 1.4 and solve for Q0. Now, we have already obtained Q0. In terms, the answer will come out to be in terms of Q obviously. Now, should I calculate the equilibrium of 2Q? I don't need to. I already know if Q0 is in equilibrium as it is given and Q is in equilibrium, the equilibrium of 2Q is inherently coming out of it. We don't need to do anything about it. Simply because the force exerted, since Q0 was in equilibrium, that means the force exerted by Q on Q0 must be same as force exerted by 2Q on Q0. So the force exerted by this Q0 on 2Q is same, let's say F. You don't need to calculate it. And secondly, the force exerted by this 2Q on Q should be same as force exerted by this Q on this 2Q. That's our BNF. So this charge is also in equilibrium. This is a beautiful question. In other multiple charge systems, there can be different conditions. If they are not in line, they can be along the corners of a triangle. And keep it in mind that if all the charges are similar, then the system cannot remain in equilibrium. That means if all are positive or if all are negative, the system cannot remain in equilibrium for obvious reasons. So that must be a mix and match of distances and polarities and magnitudes of charges to keep the whole system in equilibrium. Thank you.